So section 3.4, equations of a line. So in this section, we're going to look at several different forms for the equation of a line, and then we'll do some examples. So first, the general form for the equation of a line. So the general form for a line is ax plus by plus c equaling 0. It turns out that all lines in the plane can be put into this form, can be written in this form. So that's good. So no matter what line you have, you can always write it in general form. But unfortunately, there are, well, every line has an infinite number of equivalent or correct general forms. Well, correct forms written in general form. So it turns out that if you have, some equation of the form, ax plus by plus c equaling 0, then you can always multiply every term by a non-zero constant, and that'll give you a different general form, but it'll still be for the same line. So it turns out that you can always multiply by something, and that will by something that's non-zero for every term, and that still gives you the same. It still gives you a general form, and it's still for the same line. So even though you can put every line into this form, there's a lot of forms for every line. So because of that, we usually require some arbitrary conditions, additional conditions, so that there's only one form that we give you, and that's the form that's usually written as the answer in the back of the book. That's usually the form that I will write, and that's usually the form that they request for you to give on the computer. So we have the following additional conditions. So if it turns out that you can put it into this form, meaning that not every general form can be written this way, but some can, the ones at least that we're going to be giving you. So if there exists, let's say A, B, and C, which are all integers, so we're going to assume that A, B, and C here are integer values, and I assume that the number in front of x is positive, and I'll assume that there are no common divisors between A, B, and C. So the greatest common factor between A, B, and C is 1. So that these are A, B, and C are relatively prime. Then this is the preferred, or the one that we generally want. form for the general form. So usually when we ask you for the general form, we want it in that written in this form, that the number in front of x, the coefficient in front of x, is positive, and there are no common factors between a, b, and c, between the coefficients. Usually, we will use this, so this form is used when determining a distance to a line. So, the distance from the point, let's call it x0, y0, to the line given by the form ax plus by plus c equaling 0 is, well, the distance is ax0 plus by0 plus c over the square root of a squared plus b squared. And let's put an absolute value here. And that is the distance. Let's do the standard form. The standard form. For the equation of a line. Well, the standard form is virtually the same as the general form. It's ax plus by equals c. That's the standard form. And well, this also can be, any line in the plane can be written in this form. So any line in the plane can be written in the standard form. But as above, there are an infinite number of equivalent standard forms for the equation of a line. So because of this, again, we usually put the conditions that if a, b, and c are integer valued, we'll make the assumption that a is greater than 0 and that a, b, and c are relatively prime. If you do that, then there's only one form, one standard form for the equation of a line. Just like in the above, there's only one general form. If you made these additional conditions. Okay. Well, usually you'll use this form use the standard form. When you have a system of lines. So you have more than one line. So a system of linear equations. Let me do the slope-intercept form. For the equation of a line. So, if you can write a line in the form y equal mx plus b, then it's called the slope-intercept form for the equation of a line. Here, m is the slope of your line, and y is the y-coordinate. Of the y-intercept. Okay. Since you need a slope, then this cannot be a vertical line. So you can't you cannot write a vertical line in this form. But at least it's unique, so that's good. So with the above two cases, you could do it for any line in the plane. This, you can't do it for a vertical line. But, well, it's at least unique. You'll use this when determining the slope of a line given by an equation. So that's what we saw in the last section. We use this form. I don't know if I even told you what the form was called. I use this form to determine the slope of a line. And so that's the case that we use it for. Next, point slope form. For the equation of a line. And so y minus y1 equals m x minus x1. Okay. Where m is the slope of your line and where x1, y1 is a point on the line. So a point on your line. Again, this can't be used for vertical lines. Because you need to know the slope of the line, and while a slope does not exist for vertical lines, Basically, you'll always use this form. So always use this form, except for the special cases as given above and below. So except for, if you're trying to find the slope of a line given by an equation, use the point-intercept. If you're trying to find the distance between to a line, then use the general form. If you're looking at systems of lines, use the standard form. Next, the two-point form for the equation of a line. And so the two-point form is y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. Okay, here you're assuming that x1 is not equal to x2, and here I'm assuming that x1, y1, and x2, y2 are distinct points, are two distinct points on the line. So you have here x1, y1, x2, y2. Okay? Actually, they probably pointing the other direction looks better. Okay. When do you use this? So obviously, this can't be used for vertical lines because then you would not be able to find two distinct points where x1 is not equal to x2. So can't use for vertical lines. So again, I'm assuming non-vertical lines here. When do you use this? I myself never use it. I will just say I have never used this form. Have never used this form unless I'm forced to when the book says you have to use it. So I've never used this form. Again, it's a form, but it's not used that often. Matter of fact, usually you just find the slope of your line and then plug it into the point slope form for the equation of a line, and so you never really even use the 2-point form. Again, you only use it when they say please use the 2-point form, the intercept form for the equation of a line. So intercept form for the equation of a line is an equation of the form x over a plus y over b equaling 1. Okay. So here, of course, I'm assuming that a is not 0 and b is not 0. You don't want to divide by 0. So a is the x-coordinate of the x-intercept. B is the y-coordinate of the y-intercept. Okay, so you don't want it to, well, you want both A and B to exist, and you don't want them to equal, either of them to equal 0. So this means that this can't be used. For vertical lines, because if you had a vertical line, then you'd either have no y-intercept or you'd have an infinite number of y-intercepts. Horizontal lines, because if you had a horizontal line, you'd either have no x-intercepts or an infinite number of x-intercepts. Nor for lines passing through the origin. Because if it passed through the origin, then the x and y-intercepts would be 0. Okay. Other than that, then you're going to have, two. You'll have both an x and a y-intercept existing, and they'll be unique, and they will not pass through. They will not be 0. So, as long as you don't have them being vertical lines, horizontal lines, nor lines passing through the origin. Okay, so you would use this. Form when you are given both x and y-intercepts and they're both non-zero. Okay, if that occurs, then you would use this form. Lastly, the equation of a vertical line if you have a line of the form x equals a, then this will be the equation of a horizontal line. Obviously, only horizontal lines can be put into, I'm sorry, scratch that. If you have an equation of the form x equal a, then that's the equation of a vertical line. And of course, only vertical lines can be put into that form. Next, horizontal lines. So the equation of a horizontal line y equals b. So again, any horizontal line can be put into that form. Okay, let me do some examples. Say on page 131. Let's do problem number 1. In exercises 1 through 10, find the equation of a line. So they have here the slope is 2 and the y-intercept has the form 0, 3, meaning that the y-coordinate of the y-intercept is 3. Okay, so it doesn't tell you what form you want. In this case, we're given a slope and an intercept. And so let's use the slope-intercept form. Which is y equals mx plus b. And so y is equal to 2x plus 3. And that is the equation of a line. Let me do problem number 3. The slope is given as negative 3. The y-intercept is given as 0, negative 2. And so the y-coordinate of the y-intercept is negative 2. And so again, let's use the slope-intercept form. Because I'm given both a slope and an intercept. So y equals mx plus b. M is negative 3. B is negative 2. So y equals negative 3x minus 2. Let me do problem number 5. The slope is 1. No, the slope is negative 1. My y-intercept is 0, 2/3. And so the y-coordinate of the y-intercept is 2/3. Therefore, since I'm given both a slope and the intercept, I use the slope-intercept form for the equation of a line. Y equals mx plus b. And so y is equal to negative 1 times x, negative x, plus 2/3. And that is the equation of my line. Let me do problem number 7. M equals 3/2. No, it's not. M is equal to 3/5. And the y-intercept is the point 0, 4. So the y-coordinate of the y-intercept is 4. So again, I'm given a slope and intercept. So I'll use the slope-intercept form for the equation of a line. Y equals mx plus b. So y is equal to 3/5 x plus b, 4. And that is the equation of my line. Let me do problem number 9. The slope is 0, and the y-intercept is at 0, negative 1/2. So the y-coordinate of the y-intercept is negative 1/2. And so let's use the slope-intercept form. For the equation of a line. And so y equals mx plus b. So y is equal to 0 times x plus b. 0 times x is 0 minus 1/2 is negative 1/2. And so y is equal to negative 1/2. It's just a horizontal line. So I recall from above, That's just the equation of a horizontal line. Let me do problem number 11. M equals 3/2. And I have the point -4, +2. In exercises 11 through 22, graph the line for which the slope m and one of its points is given. Okay, so this is the rise and this is the run. So recall that slope is rise over run. So let's do this. Okay, so I have here 1, 2, 3. So we're at the point -4, +2. So I start at this point. Next, I have a run of 2. So let me go 2 in the positive x direction. I have a rise of 3. So let me go up 3 in the y direction. And so I have 2 points on the line. Let me connect those 2 points with a straight line, if I can do it. Not bad. Okay. And so this is the line passing through, passing through the point -4, +2, having a slope of 3/2. So a run of 2 and a rise of 3. Let's do problem number 13. The slope is -5/2, and a point on the line is 1, 1. Well, first off, I'll make this a rule. Since I'm your instructor, I'm a dictator, and I will make this the law, that if you notice that, well, -5/2 is the same as -5/2, which is the same as 5 over -2. I will always write, when I'm doing slopes, I'll always put the negative in the numerator. And so I'm going to dictate this as the law. You will always put the negative in the numerator. And so now this is rise over run. Okay. Let's see if I can do this. Oops. Here. Okay, so let's do 1, 2. Okay, not too bad with tick marks. So I start at the point 1, 1. I have a run of 2. So that means that since I've dictated that the the denominator will always have a plus sign, that means I'm always going to the right. So that's why I dictated that that the denominator will never have a negative sign in it. That only the numerator could either be positive or negative. So now, after I move 2 places to the right, I'll go down 5 because now my numerator has a negative 5. So 1, 2, 3, 4, 5. So now let me go 5. Oops. There. So I'm going to go down 5 in the x direction. In the y direction, sorry. And so let's draw a line through these 2 points, if I can. Wow. 1 second. Oops. 1 second. Let me draw this. Good enough. Okay. Uh-oh. Wait 1 second. I think I blanked out. I'll come back in a second. Oops. Can you see me yet? Am I still... if you guys can see the... Nope. Okay, 1 second. Let me try this again. Okay. Hopefully now that should work. Now it should come back. Got it. Okay, sorry about that. I have to twist this tablet all the way around to draw that, and I guess I accidentally twisted the screen also. Let me do problem 15. M equals 0. And we're at the point 2, 1. Okay, so in this case, well, I don't have a fraction, but I can always write 0 as 0 divided by 1, because 0 divided by 1 is certainly 0. So this is my rise, and this is my run. So let's draw this. Oops. Okay. Actually, I don't need it that low. Okay, so we're at the point 2, 1. And well, we have a rise of 0, a run of 1, but a rise of 0, so you don't go anywhere. You just stick here. So we're always on this horizontal line. Problem 17. The slope is undefined. And we're at the point 3, negative 1. So if a slope is undefined, that means that's a vertical line. So let's draw this. Okay, so we're at 3, -1. And it's a vertical line, so we just go straight up and down. So we don't have a run. So we have a rise, but no run. So because of that, then we just go straight up and down. And that's our answer. 19. M equals 3. And we're at the point 25. Well, again, just like above, I don't have a fraction, but I can make into a fraction. I can just write this as 3 over 1. You can always divide by 1. We're not doing anything. And so you should notice that in this particular case, when you're dealing with slopes, it's actually much easier to think of fractions than it is whole numbers or decimals or anything. And so this is my rise, and this is my run. So let's draw this. Those kind of get smaller at the end, so. Okay, that looked better. Okay, so let's see. We're at the point 25. And we have a slope of 3. So I have a run of 1 and a rise of 3. And should look something like good enough. Okay, so, I forgot the 3. And so that is the line passing through those 2 points. Let me do problem 21. The line passing through that 1 point, given the slope. Oh, I wrote that in black. It should be red. Problem number 21. So the slope is -2. Question. Yes, because I'm a dictator and I've dictated the denominator's positive. So in this class, since I'm the dictator, I always say, always have denominator being positive, therefore always go to the right. In the future, you can go right and left, but, since we're starting out, I always want to do something always in the same sort of direction. And so I'm being the dictator and saying let's always go to the right. So then you won't get confused. So that's the law, and you can't go against the law until your next class. Sometimes I go against it, but I'm the teacher, I can do that. So it's this is equal to, again, I can write this as a negative 2 over 1. So now you notice that the run here I wrote was positive, which means go to the right. And the rise, in this case, is negative, meaning go down. And so let's do this. Maybe I can squeeze it in here. I'll put it in right here. Actually, go over a little bit more. I can squeeze it in right here. So I'm at negative 2, positive 1. So I start here. I go 1 to the right in the positive x direction. And I go down 2 in the y direction. And so I get the following. Close enough. There. Okay. So off by a little bit, but it's close enough. Okay. So I started out at negative 2, 1. I went to the right 1 and down 2. 23. M is 4. And my point is negative 1, 2. In exercises 23 through 38, find the equation of the line in slope-intercept form. With given slope passing through a given point. So we're going to put this in slope-intercept form, but we're given a point and a slope, so it's actually easier to write it in point-slope form. So let's do that. Y minus y1 equals m x minus x1. Okay, so we have m is 4, and I have a point, so let's call that x1, y1. So I have y minus y1, 2 equals m, 4, x minus a negative 1, which is the same as x plus 1. Now I would be done, except that they tell me to put it into slope-intercept form. But the slope-intercept form is y equal mx plus b. So that means I have to solve this equation for y. So let me multiply 4 inside the parentheses. And so I have y minus 2 equals 4x plus 4. Now let me try to solve for y. So let me add 2 to both sides of my equation. So y equals 4x plus x. So this is in slope-intercept form. So this is the form that they wanted. Now, if I didn't say to put it into slope-intercept form, then you would never put it into slope-intercept form. You would just leave it in this first form up here. That's the equation of a line. 25. Usually in high school, they actually ask you to put it into slope-intercept form, and that's to check your algebra. Okay, so let's put this into point-slope form. So I have a point, and I have a slope. So my point is x1, y1. And eventually I want to put this into slope-intercept form. Y equal mx plus b. And so y minus 5 equals m negative 3 x minus 2. Let me multiply the 3, negative 3, inside the parentheses. So I have y minus 5 equals negative 3 times x is negative 3x. Negative times negative is positive. 3 times 2 is 6. Add 5 to both sides of your equation. So y equals negative 3x plus 11. This is in slope-intercept form. Therefore, I'm done. Let me do problem number 27. M equals negative 4/5. And the point is 1, 0. So let's put this into the point slope form. Y minus y1 equals m x minus x1. And so my coordinates of the point, x1, y1 are 1, 0. So y minus y1 equals m negative 4/5, x minus x1, 1. And so let's multiply negative 4/5 inside the parentheses. So y minus 0 is just y equals negative 4/5 x. Negative and negative is a positive 4/5. This is the slope-intercept form. For the equation of a line, y equals mx plus b. And so I am done. Let me do problem number 29. The slope is 0, and the point on the line is 5/3, negative 3/7. So let's use the point slope form for the equation of a line. I could also use the fact if m is 0, I know it's horizontal. Let me do that actually. Yeah, let's use the fact that it's horizontal line. A horizontal line has the form y equal b, where b is the y coordinate of any point on the line, and so therefore this is b. So y is equal to negative 3/7. And well, this is in the slope-intercept form. Because I have y equals mx 0 times x 0 plus b. So I don't have to say y equals 0 times x minus 3/7. I already know it's 0 times x is 0. So we still say that this is in slope-intercept form. 31. M equals 5/2. And a point on the line is 2/5. 2, 5. So let's use the point slope form for the equation of a line. Y minus y1 equals mx minus x1. I want to put this into slope-intercept form. Y equal mx plus b. And so the point on the line x1, y1 is just 2, 5. So y minus 5 equals 5/2 x minus 2. Let me multiply 5/2 inside the parentheses. So I have y minus 5 equals 5/2 x. Positive times negative is negative. The 2's cancel. You just get 5. Let's add 5 to both sides of your equation. And so the 5's cancel. And you get y is equal to 5/2 x. Well, again, this is in slope-intercept form. In this case, b, the y-coordinate of the y-intercept, is just 0. But again, you call it slope-intercept form. You don't have to say plus 0. 33. M equals negative 2/3. And the point is 1/2, 3/4. Okay, so let's use the point slope form for the equation of a line. Y minus y1 equals mx minus x1. And we want to eventually put this into slope-intercept form. Y equal mx plus b. Okay, and this is the point x1, y1. So I have y minus y1, 3/4 equals m negative 2/3 x minus x1, 1/2. So let's multiply. Negative 2/3 inside the parentheses. So I have y minus 3/4 is equal to negative 2/3 times x is a negative 2/3 x. Negative times negative is positive. 2/3 times 1/2, well, the 2's cancel. So I just get 1/3. Or you can say 2 times 1 is 2, 3 times 2 is 6. 2/6 the same as 1/3. Let me add. Actually, maybe I'll do it this way. I'll do it so I don't have fractions at the beginning. Let me multiply both sides of my equation by 12 to get rid of the fractions. So I have 12y minus 12 divided by 4 is 3 times 3 is 9 equals, well, 12 times negative 2/3. Positive times negative is negative. 12 divided by 3 is 4 times 2x is 8x plus 12 divided by 3 is 4. Add 9 to both sides of your equation. So I get 12y is equal to negative 8x plus 13. Divide every term by 12. So y is equal to negative divided by positive is negative. I can divide both 8 and 12 by 4. So negative 2/3 x plus 13/12. And that is your equation in slope-intercept form. Obviously, it would have been much easier if you would have stopped at the very first step if they didn't tell you to put it into slope-intercept form. And of course, that's why they ask you to do it in high school, because it gives you a lot of practice in arithmetic. Let me do problem 35. M equals negative 7/9, and the point is 4, 0. Oh. And so I'll use the point slope form. For the equation of a line, y minus y1 equals mx minus x1. And so this is the point x1, y1. And we want to put it in the form of the slope-intercept form. Y equals mx plus b. Okay, so, I have here y minus y1 is 0 equals m negative 7/9, x minus x1, 4. And so I have y is equal to, let me multiply negative 7/4 inside the parentheses. So I have a negative 7/9 x. Negative times negative is positive. 7 times 4 is 28, all over 9. And that is in the slope-intercept form. So I'm done. Okay, 37. Same thing. M equals negative 4/7, and the point is 6, 0. Okay, let's put this into point slope form. Y minus y1 equals mx minus x1, and we want to put this into slope-intercept form at the end. Y equals mx plus b. Okay, so this is the point x1, y1. So I have y minus y1, 0 equals m negative 4/7, x minus x1, 6. Okay, so let's multiply negative 4/7 inside the parentheses. Y minus 0 is just y. Negative 4/7 times x is negative 4/7 x. Negative times negative is positive. 4 times 6 is 24. 7 times 1 is 7. And so I've written the line in slope-intercept form. Problem 39. In exercises 39 through 52, find the equation of the line in standard form with given conditions. So it says that it passes through the point 2, 1 and is parallel to the line 4x minus 3y equals 1. Okay, so the first thing I want to do is determine the slope of this line. And so let's first determine the slope of this line. So I'll put it into slope-intercept form. So let me subtract. Let me subtract 4x from both sides of my equation in order to isolate y on one side of the equation. So I have the negative 3y equals negative 4x plus 1. Let me divide both sides of my equation by negative 3. And so I have that y is equal to negative divided by negative is positive. 4/3 x. Positive divided by negative is negative minus 1/3. So in this case, the slope of the line is 4/3. The slope of a line parallel to this given line is also a slope of 4/3, since two lines that are parallel have the same slope. I am given a slope and a point, so let's do the point slope form for the equation of a line. Y minus y1 equals m x minus x1. So I am given a point, x1, y1, and I'm given a slope. And so y minus y1, 2, equals m 4/3 x minus x1, 2. Let me multiply, and I would be done, except that I want to write this into standard form. So the equation of a line in standard form is ax plus by equals c, where a, b, and c are integers, where a is greater than 0, and these are relatively prime. The coefficients are relatively prime. Okay, so let's do this. So let me multiply 4/3 inside the parentheses. So I get y minus 1 equals 4/3 times x is 4/3 x. 4 times 2 is 8. 3 times 1 is 3. Let me multiply both sides of my equation by negative 3. The reason I want to multiply by negative 3 is because if I'm going to bring the x to the other side of my equation, and when it's on the other side of the equation, I want it to be positive, then on the right side of the equation, I want it to be negative. So let's multiply by a negative 3. So if I do that, I get negative 3y. Negative 3 times positive 1. Negative 3 times negative 1 is a positive 3 equals. The 3's cancel, so I get a negative 4x. Negative times negative is positive. The 3's cancel, so I get 8. Next, I want x's and y's on the same side of the equation. That's what it means to be in standard form. So let's add 4x to both sides of my equation. And, well, I don't want any constants on this side, so I'll subtract 3 on the left side. So I'll subtract 3 from both sides of my equation. So if I do that, I get 4x minus 3y equals 5. Notice that 4, 3, and 5 are integers. The coefficient of x, 4, is greater than 0, and I cannot divide 4, 3, and 5 by anything other than 1. Therefore, this is the desired equation. This is the equation of a line written in standard form, which is parallel to the given line and that pass through the point 2, 1. Okay. Let me do problem number 41. Yes. When do these problems? Oh, it was in the instructions. So the instructions said, find the equation of the line written in standard form with the given conditions. So usually we specify, well, I wouldn't say that. Sometimes we will specify in the problem if we want it in a particular form. They usually do that, especially on computers, just because it's easier to write a program where you actually have a specific form that you're looking for. But that's just because it's easier to compute to write a program that way. Usually on books, we also ask to write in a specific form, only because it's easier in the back of a book to write your answer in just one form. So the answer is we almost always specify it, but that's only because of the limitations of the technology. But that's the only reason, really. 41. Oops. And also because we want to know if you know all of the forms for the equation of a line. 41. So it passes through the point negative 3, 2, and is perpendicular to the line 2x plus y equals 3. So again, we want to write this in standard form. So first thing to do is figure out the equation, the slope of the line. And so let's solve this equation for y. So let me subtract 2x from both sides of my equation. So in this case, I get y equals negative 2x plus 3. So that says that, well, the slope of my line is negative 2. The slope of a line perpendicular to a given line is its negative reciprocal. So let's change the sign. So I change it from negative to positive. And I take its reciprocal. So I interchange numerator and denominator. And so the slope should be positive 1/2. I have a point and a slope. So first, let me put this into point slope form. So y minus y1 equals mx minus x1. But eventually, we want to put this into standard form. And so standard form is ax plus by equals c with all these other strange conditions. I want a, b, and c to be integer valued. I want a to be greater than 0. I want the greatest common factor of A, B, and C to equal 1. Okay, so let's first find the equation. So I have here the point x1, y1, and I have the slope being 1/2. So I have y minus y1, 2, equals m, 1/2, x minus x1, a -3. Let me multiply 1/2 inside the parentheses. So I have y minus 2 equals 1/2 x plus 3 times 1/2 is 3/2. Let me multiply both sides of my equation by -2 because I want the x to be negative on the right side, positive on the left side. And so -2 times y is -2y. -2 times -2 is a +4. Negative times positive is negative. The 2's cancel, so you just get -x. Negative times positive is negative. The 2's cancel, so you just get 3. Add x. Subtract 4 from both sides of your equation. And so you get x minus 2y equals -7. And that is an equation in standard form where you have all the coefficients are integer valued. The coefficient of x, the number in front of x is positive, and there are no common factors between 1, 2, and 7. Let me do problem number 43. So it passes through 4, 3. And is perpendicular to 3x minus 2y plus 4 equaling 0. Yes. Oh, can it be written that way? Yeah, it could be written that way. We usually write x's first, but I don't think it would. I'm just thinking about the computer. I don't think it would mark you wrong if you wrote it in that way. I think it would still mark you as correct. I'll have to check on that, but I'm pretty sure the computer would say, yeah, that's close enough. Okay. Okay, so let's solve for y. Let me subtract 3x. So I want to first solve for y. So I want to isolate y on one side of my equation. Subtract 3x, 4 from both sides of my equation. So I get -2y is equal to a -3x minus 4. Divide both sides of my equation by -2. And so I get here y is equal to +3/2 plus 2. And so that says that the slope of my line is a +3/2. The slope of a line perpendicular to this line will have a slope that has a negative reciprocal of the previous slope. So the slope was positive, therefore this slope will be negative. And I had 3/2, so let's take the reciprocal, 2/3. So the slope of a line perpendicular to the given line has a slope of -2/3. Let me use the point slope form for the equation of a line, since I'm given a point and a slope. So I have y minus y1 equals mx minus x1. And I want to put this into standard form. Ax plus by equals c with the arbitrary conditions that a, b, c are integer valued, a is greater than 0, and a, b, and c are relatively prime. Okay. And so let's plug in. So the point is 4, 3. So y minus 3 equals m, negative 2/3, x minus 4. Let me multiply negative 2/3 inside the parentheses. So I get y minus 3 is equal to negative 2/3 x. Negative times negative is positive. 2 times 4 is 8/3. Let me multiply both sides of my equation by 3. And so I get 3y minus 3 times 3 is 9 equals positives times negative is negative. The 3's cancel. 2x. Positives, the 3's cancel, so I just get 8. Add 2x, 9 to both sides of my equation in order to isolate x and y on one side of the equation. And so I get 2x plus 3y equals 17. And that is your answer. Let me do problem 45. So it passes through 4, 3. And is parallel to 45. Parallel to 3x minus 2y plus 4 equaling 0. Okay, so let's do this. So first let's solve for y. So subtract 3x, 4 from both sides of my equation. Oh, it's the same line, isn't it? Subtract 3x, 4 from both sides of my equation. So negative 2y equals negative 3x minus 4. Divide by negative 2. So you have y equals positive 3/2 x plus 2. So therefore the slope of the line is positive 3/2. Therefore the slope of a line parallel to the given line also has a slope of 3/2. I have a point and a slope. So let me use the point-slope form for the equation of a line. Y minus y1 equals m x minus x1. And I'll put this into standard form at the end. Ax plus by equaling c. Okay. And so, where a, b, and c are integer valued, A is greater than 0 and A, B, and C are relatively prime. So the point is 4, 3. So y minus 3 equals m 3 halves x minus 4. Multiply 3 halves inside the parentheses. And so I have y minus 3 equals 3 halves x minus, actually I won't even reduce, 12 halves. Let me multiply both sides of my equation by negative 2. And so I have negative 2y plus 6 equals negative 3x plus 12. Add 3x. Subtract 6 from both sides of your equation. So I have that 3x minus 2y is equal to 6. And this is the equation of the line parallel to the given line passing through the given point. I still have a lot of problems to go, and so I guess that's it for today. I guess I'll end at problem 45. And then on tomorrow, Tuesday, I guess I'll finish off some more problems from this section. Any questions about anything that I did? I went over a little fast at the end, but no. With parallels became negative. So the fact if it's positive or negative has nothing to do with it if it's parallel or not. For two lines, when they're parallel, their slopes are equal. So whatever slope you're given, oh, I see. So if you're given some slope, oh, I guess they were all positive, weren't they? It didn't matter. So if you're given, say, this slope of negative 7 halves, negative 7 ninths, and you're looking at another line parallel to it, the parallel line would also have a slope of negative 7 halves. Now, if you're looking at a perpendicular line, then a perpendicular line would be its negative reciprocal. This would change from negative to positive, and the numerator and the denominators would interchange, so it would be a positive 9/7. But if you have a parallel line, all that means is that the slopes are the same. And so whatever the slope is of the original line, the new line will have the exact same slope. So if the original slope was negative, if this was a negative 3 halves, then the line parallel to it would also have a slope of negative 3 halves. Any questions about that? Okay. Any other questions about anything? Okay. That's it for today, and I'll see you guys tomorrow.